In today's video, we will learn partial fraction decomposition for Calculus 2. Partial fraction decomposition is an advanced integration technique used to simplify advanced integrals. So let's take the integral of -1 to 1 of 5x over x plus 4 squared times dx. This problem allows us to use partial fraction decomposition as a valid way to integrate this function. The way we do it is we need to make a over something plus b over something. For this specific problem, take a look at the denominator, x plus 4 squared. X plus 4 squared, this is called a linear repeated factor because of its linearity, if that's a word, linearity. So because of that, what we have to do is we have to account for it twice. What it means is you take the base, which is x plus 4, then you take it squared. That's how you do a partial fraction decomposition with linear terms. You basically just repeat the term and square it. If it was cubed, then you do the same thing that you see here. You do x plus 4 and then x plus 4 squared and then plus c x over x plus 4 to the third, right? So in this specific problem, it only goes up to square, so we can stop here. Now what you're going to do is you multiply this a and b by x plus 4 squared, and what you'll see is that one of the x plus 4's cancels out in a, and actually both of them will cancel in b. So you'll be left with a over x plus 4. Oh, wait, no. You can put on the top x plus 4 plus b, and then there's nothing for b. So it's just like having a 1 here. Because if you multiply this top by x plus 4 squared, what you'll see is both of these just cancel, and you're just left with b to the 1, right? And it's the same thing with a. So if I show you, we have x squared plus, or not x squared, x plus 4 on the top, right? Only one of them will cancel because it's squared. So you're still left with an x plus 4 up here. Okay? So now, what does this equal to? We dealt with this denominator portion here, right? So we dealt with that. Now we need to deal with this top portion. What we're going to do is we're going to set that numerator equal to our entire a and b function. So remember, this is just b times 1, so you can kind of just get rid of the 1. You don't really need it there. So you'll just be left with 5x equals a x plus 4 plus b. So now what our goal is for this is we're trying to find a and b, and we need to let x equal something so we can get a and we can get b. So if we wanted to, let's just say, find b, if we set x equal to -4, this term right here is going to cancel out completely because -4 plus 4 is 0, a times 0 is 0. So you're really just going to be left with 5 times the -4 equals b. Now no, b is equal to -20. Now with b equal to -20, to find a, since we don't have any other variable like c or d or something like that, because we just have a left, we can set x equal to anything that doesn't make it 0. So like, for instance, we can make x equals 0 here, because 5 times 0 equals a times 0 plus 4, right? This term is still going to be positive, right? It's not going to be a negative term, or a 0 term. We do minus, well, what is b? -20, so minus 20. So now what we can do is we can simplify. 5 times 0 is just 0 equals 4a, right? Because 0 plus 4 is just 4. And multiplied by a is 4a minus 20. Now we add 20 to both sides, and you're left with 20 equals 4a. If you divide both sides by 4, you get a was equal to 5. Now, remember, we still had our integral up here, so we can rewrite -1 to 1. And we have, our formula was a over x plus 4 plus b over x plus 4 squared, right? So let's put a. So we have 5 over x plus 4. And then plus, what was b? -20 divided by x plus 4 squared. So now what I'm going to do is I'm going to split this integral. We're going to split this into two different integrals. We're going to take the integral from -1 to 1 of 5 over x plus 4. And then minus, the reason why is because this negative right here, negative and a positive makes the negative, so we can just factor the negative out. Minus the integral from -1 of 20 over x plus 4 squared. Right, and we still have our dx's on each side. So now we can take each integral. Let's do the integral 1 first. Let's do the left side of the integral. So we're going to let that be -1 to 1 of 5 over x plus 4 times dx. So to evaluate this one, what we're going to do is we can take a constant factor of 5, right? So it's going to be 5, -1 to 1. And we know 1 over something, like 1 over u or 1 over x or something like that, is just going to be the natural log of the absolute value of u. So we're going to have our constant 5 times the natural log of the absolute value of x. And remember, we still have our bounds. Now we can evaluate the upper bound. 5, absolute value of 1 plus 4 equals 5 natural log. You can take rid of the absolute value and just keep 5 there. Now we do the lower, which is -1. So 5 absolute value of -1 plus 4 is equal to 5 natural log 3. So now what we can do is we can take f of b minus f of a, which will get 5 natural log 5 minus 5 natural log 3. Now remember your logarithmic, your properties, right? We have these constant 5s in front of each, but we have natural log of 5 minus natural log of 3. We can turn that using the quotient rule for logs into 5 natural log of 5 over 3, right? So that is our integral 1. Now we need to find integral 2, right? So our integral 2, which we can have is -1 to 1 of 20 over x plus 4 squared times dx. Now, there's a few ways you can evaluate this. The way I'm going to do it is I'm going to rewrite this with a negative exponent. I'm going to rewrite this as the integral from -1 to 1 of 20 x plus 4 to the -2 times dx. Now, what I'm going to be able to do here is I'm going to be able to use the power rule for integration, which is the rule x to the n plus 1 divided by n plus 1. If I add 1 to the power and divide by that same amount that I'm putting in the power, which is n plus 1, I'll get the integral. Or actually, we won't even have the integral anymore. We just have these brackets from -1 to 1. So if we just pull this out for a second, we'd have 20 to the x plus 4. N plus 1 would be -2 plus 1. We get -1 divided by that -1. That gives us -20 x plus 4 to the -1. And we can rewrite it as -20 over x plus 4. So now let's put that back in. And now we have this. Now what we need to do is we need to evaluate the upper bound and the lower bound. So let's start with the upper bound. -20 divided by, what is x plus 4? Well, our upper bound is 1 plus 4. This gives us -20 over 5, which equals -4. Now we have our lower bound, which we said was, where is that? Oh, yep. -20 divided by -1 plus 4. This equals -20 over 3. Now what we can do is we can use f of b minus f of a, and we'll have -4 minus -4. Don't forget your negatives there. This will become -4 plus 20. Now we can get a common denominator by multiplying the top by 3 and the bottom by 3. This will give us -12 over 3 plus 20 over 3, which is equal to 8 over 3. Now remember what we said to find our final. we said that it was going to be the integral of 1, which is this one, minus the integral of this one, which is 2. So the integral of 1 minus the integral of 2 will give us our answer. Integral 1 we said was 5 natural log 5 over 3, which is right here. So 5 natural log 5 over 3 minus 8 over 3. This is our final answer. 5 natural log of 5 over 3 minus 8 over 3. Let's take the integral of 8x squared plus 5x plus 37 divided by x plus 1 times x squared plus 4 times dx. Now, this has a repeated linear term right here like we discussed before, but it also has this term right here, which is called an irreducible quadratic, which requires us in the numerator to have a linear factor, such as bx plus c. So let's look at what that looks like. We have this 8x squared on the top still, plus 5x plus 37 equals a over x plus 1 plus that linear term, which was bx plus c, over x squared plus 4. That's a rule you have to know and be able to identify where a quadratic is irreducible for partial fractions. Now, if we multiply the numerator by x plus 1, x squared plus 4, you'll see that we still have this on the left side. And the a to the x over x plus 1, the x plus 1 will cancel, and you're just left with a x plus square, or x squared plus 4. Plus, we have this bx plus c term, and then multiplied by our x plus 1, because our x squared plus 4 both cancel. So now we are going to see what we can do to make either a, b, or c cancel. So immediately, just by looking at this, we can get b, or no. If we let x equal -1, then b and c will both cancel out. And we'll just be left with a to solve for. Because -1 plus 1, right here, if I let it equal -1, -1 plus 1 is 0. And everything that we multiply in is just going to become 0. So if we let x equal -1, I'll write that here, x equals -1, then we'll have here 8 -1 squared plus 5 times -1 plus 37 equals a -1 squared plus 4. Simplifying the left hand side will give you 8 minus 5 plus 37 is equal to 5a. This is just 40 on this side equals 5a. And a will be equal to 8 if you divide both sides by 5. Now, knowing that we have a, we need to get either b or c. If we let x equal 0, b will cancel out completely, but c will be able to stay. So that's what we're going to do. Let x equal 0. 8 times 0 squared plus 5 times 0 plus 37 equals 8, because we found a, times 0 squared plus 4 plus b times 0 plus c times 0 plus 1. Simplifying the left-hand side will give us 0 plus 0 plus 37 is equal to 0 squared plus 8 times 0 squared plus 4. 0 squared plus 4 is going to just be 4 times 8, which is 32. And notice the b times 0 will cancel out. And if you do 0 plus 1, which is 1, if you jump the 1 times c, you're just left with c. And subtracting both sides by 32 will give you c is equal to 5. Now all we have to do is find b, which we can let x equal anything as long as b doesn't cancel. So let's let x equal 1. If we do that, we'll have 8 times 1 squared plus 5 times 1 plus 37 is equal to 8 times 1 squared plus 4 plus b times 1 plus 5 times 1 plus 1. Let's simplify the left side first. 8 times 1 squared is just 8 plus 5 plus 37 is equal to 1 squared plus 4 is just 5. 8 times 5 is 40. Now we have this term over here. We have this b times 1 plus 5 times 1 plus 1. Well, 1 plus 1 is just going to be 2. 2 times b is just going to be plus 2b. And then 5 times 2 is just going to be 10. So we have plus 10. So now let's simplify the left. So 8 plus 5 plus 37 is 50, which equals 2b plus 50. Notice we can subtract 50 from both sides. You get 0 is equal to 2b. And if you divide both sides by 2, you'll be left with b is equal to 0, which makes that entire term cancel, the b times x term. Well, we'll see that right now. So now our integral is just going to be a, which is 8 over x plus 1, plus, what is b? Well, that's just 0 times x, plus what is c? 5, right? Divided by x squared plus 4 times dx. Now 0 and x cancel, and you'll be left with the integral of 8 over x plus 1 plus x. Now, I'm going to split this. You don't have to split this integral. You might be able to just do it in your head, but I'm going to split it just for the sake of it. I'm going to split it and make it the integral of 8 over x plus 1 plus, or times dx, plus the integral of 5 over x squared times dx. Now let's evaluate integral 1. Integral 1 will let be 8 over x plus 1 times dx. This is going to simplify into the 8 natural log absolute value of x plus 1. Using the natural log rule, natural log of, or the 1 over u is equal to the natural log of the absolute value of u for integrals. Then we can simplify integral 2, which we'll have is the integral of 5 over x squared plus 4 dx. Now this should be looking like a inverse tangent integral. And the reason why is because I can factor out this 5 outside the integral, and you now have 1 over x squared plus 4, right? dx. And we know that 1 over a times tan to the negative 1 of x over a is our inverse tangent rule. And where that a is this constant, this 4 right here, squared. So 2 squared gives us 4. So a, the base, has to equal 2. So you now have 5 times 1 over 2 times tan negative 1 of x over 2. Right? Now that 5 can jump in, and you'll be left with 5 over 2 tan negative 1 of x over 2. Now we need to look at both of them and look at this plus sign right here. It might be kind of hard for you to see actually, but there's a plus sign there because we were taking integral 1 plus integral 2 to get our final sum. So integral 1 plus integral 2 will equal our value. We said integral 1 was equal to the 8 natural log absolute value of x plus 1. And now we can plus integral 2, which was 5 over 2 tan negative 1 x over 2. And we can add plus c at the end of it because this integral is undefined. That is the final answer. Hopefully partial fraction decomposition makes a little bit more sense to you guys. You guys can use, practice problems or whatever. Use AI to help you if you need it. But hopefully that gives you some clarity on how partial fractions will work. Obviously there can be more, difficult examples, but generally in a Calculus 2 class, repeated linear factors and irreducible quadratics come up quite common. But sometimes teachers or professors will hide the partial fractions with other terms, and it might be not easy to see just with the naked eye. You might have to use completing the square, for example. That's a common one.